Alright, nerds, so we're going to talk about a man Newton and his third and final law of motion, as far as we're concerned. Okay, so Newton's third law of motion. Essentially, it's the reason we can look at this rocket here, or shuttle, sorry, and watch it take off. Newton's third law, relies heavily on his second law, like they inform one another, and we'll get to that in a second. So, the law, what does it say? For every force, there's an equal force acting in the opposite direction. So, man down here is pushing against the wall with 100 newtons. The wall's pushing back with him at 100 newtons. It is more commonly said, though, like this. For every action, there is an equal and opposite reaction. In other words, if he pushes against the wall pushes back. Okay. What it means, all forces exist in pairs. They don't exist outside of pairs. And it relates to F equals ma. So the effect of the force on the two separate objects relates to the mass of them. Basically, the forces are going to be equal, but the masses of them is what has the major effect. Okay, so action-reaction forces. So the ball here has been thrown at the wall, and it pushes against the wall, and we call this the action force. So F ball, that's the action force. Now the wall pushes back. This is the reaction force. Now both accelerate away from each other, but the wall being part of a much, much larger mass, like the house, it accelerates very slowly to the point where we can ignore it and just pretend that it doesn't, but it actually does, just a little bit. Alright, so just quickly, it's the force from the wall which causes the ball to bounce away, not the force of the ball. It pushes into the wall. Alright, so here we've got a guy being blown off his feet. Explosive gas from the bullet pushes the rifle. Okay, so the bullet actually pushes the rifle, and it's the rifle that pushes the bullet. Okay, so the rifle accelerates away from the bullet, and that's what we call recoil. So the rifle accelerates away from the bullet, and at the same time the rifle pushes against the bullet, and the bullet accelerates away from the rifle. So the reason that the bullet flies off is not because the bullet has caused an explosion behind it. It's because then the rifle is pushed back against the bullet. So the bullet is much lighter, so it accelerates much faster. Okay, so they're both going to accelerate away, but the bullet will accelerate much, much faster because it weighs much, much less than the gun. Okay, so movement, when we talk about moving on the surface of something, that's the result of action forces. So here we see the foot, it pushes down on the floor, like it pushes backwards against the floor, but the reason you move forward is that the floor pushes you forward. Okay, so the floor pushes back. This is all very counterintuitive. Okay, we appreciate that. This is not the way we often think of the world. So it's important to know that movement occurs when an object reacts and pushes back. A very easy way to see this is someone stepping off a boat onto the jetty here. When the sailor, with his red beard, pushes against the boat, okay, he moves forward, but the boat weighs a lot less than the Earth, so the Earth normally doesn't react so much, but when he pushes forward, the boat moves backwards. Okay, so he pushes forward, the boat moves away, but it's the boat that's pushing him forward, and he is pushing the boat backwards. Alright, the shuttle, we're back. So the shuttle pushes large amounts of gas down, like it pushes down on the gas out the exhaust, so the gas comes out of the exhaust here because the rocket is pushing it down. That's the action force. The gases push back with equal force to the shuttle, and that's the reaction force. So when the force that the shuttle is pushing down the gas with exceeds the gravitational pull, the shuttle lifts off. So you see here the rocket pushes down with 35 meganewtons, that's 35 million newtons. It pushes down on the gases, and then the gases, force gas, oh sorry, I'm pointing as if you can see my fingers, force gas pushes back up. Okay, so here's a little summary of it basically, and I would suggest you get this down where you can ignore that. That's an old textbook. So it's very important that it's not intuitive. You understand that it's not the way we think about the universe naturally. So for every action force, there is an equal and opposite reaction force. So it tells us that force come in equal and opposite pairs that act on different objects. And when a force acts on an object, it accelerates an object. So for examples, the baseball pitcher, he exerts a force in throwing the push ball, but the ball exerts the exactly same force on the back of his hand. But the ball is much lighter than the pitcher. If the ball was heavier, the pitcher would fly backwards. Okay? And so forth and so forth. Alright, I hope that wasn't too complicated. Bring your questions to class, and yeah, we can do some experiments. See you later.